Good morning, everyone. Glad to have you here. So it's Saturday morning here in Washington D.C. It's 11 a.m. on the East Coast here, and happy to be here for this virtual global Azure Day. Glad you can join me at this hour. Today we're going to talk about how to build real-time inference pipelines with Azure Stream Analytics and something called ML.NET, which is an open source library for machine learning. I think it's going to be so much fun this morning. I'm really excited. We're going to spend a bit of time to start off with on some slides just to get some foundation on what Stream Analytics is and what machine learning in C# is. But we will quickly switch over to a demo instead. We will actually try to build this in Visual Studio. So that's going to be awesome. If you have any questions during the talk or the stream, just feel free to put them in the chat, in the Twitch chat. They should pop up on my screen, and I should see them, and I can try to answer them in real time. If not, feel free to reach out to me on Twitter, LinkedIn, whatever social media suits you best, and I'm happy to answer all your questions afterwards as well. But to start off with a little bit about myself. As I said, my name is Alexander Slotte. I am based out of Washington, D.C., but I am originally from Sweden. Came here about 4 years ago now. I'm a Microsoft MVP as of February this year in developer technologies. And I also work for a company called Excella as a managing consultant. I organize a meetup in DC monthly together with some co-organizers, and we are currently running virtual meetups. So if you want to tune in to one of our talks, definitely do so. It's open for everyone. If you want to speak, I also encourage you to submit a talk. We would love to hear from you. I also want to mention that this portion right here, I don't have any URL for it, but there is going to be a conference at the end of May called the Virtual ML.NET Community Conference. It's a conference for everything regarding ML.NET. So if you like what you hear today, definitely tune into that conference at the end of May. We have 2 days, one day with a workshop from Bree Ackman and Louise from Microsoft. And the second day is going to be full of sessions from passionate people around the community around the world. So if you like what you hear today, I suggest you check out that conference. All right, so today, what are we going to do? Well, let's have a quick look at what machine learning internet is, and also get some ideas of what Stream Analytics is and what we can do in Azure here. Well, after that, we're going to switch over to a demo, and we're going to build a streaming pipeline from scratch, including the machine learning model, and pipe it into this real-time data feed of data, and kind of take out some of the data, make a prediction of the data, and put it back into the stream again. And the domain we're going to work with today is fraud detection. So that stream is going to consist of real-time transactions, so real-time transactions of data with payment type, with amounts and so forth. And we're going to determine if a transaction in that stream is fraudulent or not. So to kind of look at the architecture of the idea here, we can envision something like this in Azure. For example, we can have an event producer on the left here, which spits out a lot of events, in this case transaction. They can go to an event tab, and Azure Stream Analytics can then listen to that event tab to make some aggregation operations on that stream. And we'll look at that a bit later on how it looks. And we can then pipe in a C# user-defined function with ML.NET in it to make predictions on that real-time moving stream. And then you can envision things like egress operations on that stream. For example, we can just pump all the data to a Power BI dashboard, or we can put it in a service bus queue to make different actions based on what we find out, if something is fraudulent or not. You can think about maybe blocking an account or something like that, or emailing a customer that, hey, something weird is going on with your account, you may want to check it out. So that's kind of what you can think of in general. And if you want to set up this architecture yourself, I do have a workshop on my GitHub account, which has all the ARM templates for Azure, so you can set this up yourself. We are just going to focus on the small portion in the middle today, which is going to be the Stream Analytics job, as well as the C# UDF function, because that's something that is very new. It's released maybe a month or two ago, and I think it's just really, really cool and hasn't got enough attention from the community yet. What you'll need to do this yourself, if you want to try it out later, is of course .NET Core. It's always good to have on your computer. Visual Studio, as well as an extension to Visual Studio called Azure Data Lake and Stream Analytics Tool. And this extension, as we'll see a bit later, is going to be very useful to have templates for these Azure Stream Analytics jobs in Visual Studio. It's going to allow you to hook up to cloud input or local input of your streaming data. But we'll look at it a bit later. But to start off here, let's think about what Azure Stream Analytics is, because I'm not sure if everyone is fully aware of what you can do with it and what Stream Analytics really entails. We have streaming data all around us, right? Today, you have it on social media, you have it on your Waze app, you have it when you're driving cars around. Well, you probably don't drive as much to work anymore with the tolls, but toll systems is also real-time transactions and real-time streaming. And of course, you have it for something like fraudulent transactions at your bank. In general, a stream consists of a continuous sequence of events, and they're all generally very small. We're talking about kilobyte size here. We're not talking about large images or something like that. They generally have a timestamp and have a value, and the value can be kind of whatever you want it to be, really, as long as it's small. The type of events can be, or the format of the events can be JSON or CSV or your own custom format as well. And there's support in Azure Stream Analytics to deserialize the format you have chosen. I generally prefer JSON because it's a very versatile and lightweight format, but it's completely up to your own choosing, honestly. The difference between stream processing and batch processing is that batch processing is something we're very aware of today and something most of us use today. For example, you run a query on a database to get the financial records of the month. Maybe you want to just get an aggregation of something data in your database. What you do then is that you run this query on an entire data set. It can take a long time to run, minutes to hours, and you don't really get that insight directly that can lead you to an actual insight or actual path change, I guess, for your company. Stream processing, on the other hand, just works on really small amounts of data, and it works on a small data stream, so a time window. So the insight is going to be near real time, and it's going to be just working on a subset of data, not an entire table, so much quicker. And by doing that, you get the ability to also make decisions just on a real-time basis that could actually generate more money for your company or save lives, for that matter. So when we talk about Azure Stream Analytics, the general anatomy of that is in the center here, we have Azure Stream Analytics as of this icon right here. And we have ingress and we have egress to a Stream Analytics job. When we talk about ingress, that's just a fancy word for inputs, and there are numerous those. And egress are actions or things or sinks in some ways where you want the aggregation operations to end up with. There are also integrations to Azure Machine Learning and the classic Azure Machine Learning Studio as well. So you could call a machine learning function straight from the job to get real-time inference in that way as well, if you want to work with your own cloud-provided machine learning service. It's awesome. It works really well. It's not my preference. I enjoy having my machine learning model at hand and kind of serve it as I want to, offline or online. And just having a C# UDF function instead, where you can serve your model, is just going to be more versatile for me personally. And we'll look at that in just a bit. When we talk about ingress to a Stream Analytics job, we're talking about where can the data come from. And there's two distinct sources, or two groups of sources, I think. The first one is blob storage and a SQL server. And you may say, hey, that's not a real-time stream, like it's very stagnant data. And you're right, it's not a real-time stream. It's reference data. So it's data you can use to enrich the stream that you have. For example, if you look at the toll system, and we have a camera taking pictures of all the cars passing by, and you kind of parse out the plate number, you need some correlation of the plate number to understand where to send the toll fees or the bills, right? So you may want to reference that plate number with a database that will actually get the payment information or the address of that car owner. And that information is going to consist or be somewhere in a blob storage or in a SQL Server database instead. So that's slow moving data that you can use as reference data. The second group is the event hubs or IoT hubs. Those, of course, are real-time streams, so you can use that for fast-moving data instead. Egress is, I think, really where this job shines. You have multiple options here. You have Power BI, of course, if you want to dump your data straight out to the stream. We have Azure Functions if you want to make actions just directly on something. Cosmos DB, blob storage as well, table storage, data lakes, and service bus. There's just many options here of your choosing. So depending on your use case, one may make more sense than the other. For example, you can dump everything in Cosmos DB to do batch processing later, or you can take actions directly with a service bus or an Azure function. All right, so the really cool thing with Azure Stream Analytics is the temporal windows. And that's the way we group the data in some kind of logical sense so we can make aggregation operations on it. And remember, we are not working on tables here. We are working on moving data streams. And with temporal windows, we can make that happen. There are a number of different temporal windows: tumbling window, hopping window, sliding window, session window, but they all kind of had the same idea. So let's just look at the first two of these. When it comes to the tumbling window, we can think of something like this, where the blue rectangle bars here are the time window, and the green quadrants here are the actual events in the stream. So 1, 2, 3, 4, 5. So we'll see here that the time windows are tumbling, meaning that they are equal lengths and they're not overlapping. So one event is only going to be in one window. For example, we can say, I want windows of 10 seconds, or sorry, 1 minute, and you will get the aggregation of that minute. So for example, you say, give me the average number of tweets on this topic per minute. That's kind of what you're going to get here. But you only get an output every minute when you do this, which is could be good, could be bad, depending on use case and your scenario. Hopping window is one that I use more, and it's very similar. It has equal length windows, but they are overlapping. So that means that you will define a window size, but also the interval on which these windows are going to hop. So you may say, make an aggregation of every minute, but please hop every 10 seconds, which means that we also get an output every 10 seconds. And it also means that an event can be a part of more than one window. For example, number 3 here is more than one window, and so is number 4 and 6. So you'll have this kind of averaging effect instead, which in some use cases can be useful, and in some use cases it's not so useful. So it really depends on your scenario. And when you go to how we actually would write this query, the really cool thing about Azure Stream Analytics is that we are using SQL. So if you're familiar with SQL, you will feel right at home. And a normal query that's very simple is something like this, where you project all your columns, or the specific ones you want, into an output from an input. And notice that we actually are selecting into something from something, and it always gets me, instead of selecting star from, right? And we can, and this is optional, you can group by a time window. If you don't group by a window, you won't be able to have aggregation functions like max, mean, and those so forth. But you can still just pump all the data out to Power BI dashboard. So if you want to connect a source to a Power BI real-time dashboard, you can use this job just to kind of funnel all the data through it straight away. Pretty useful. But in general, it's if you're familiar with SQL, this should be no news to you really. There are some caveats, there's some nuances on the language, of course, but they're really easy to pick up, and you'll feel pretty comfortable and familiar after not so long using this. All right, so that's Stream Analytics. Let's switch over to machine learning, and let's see how we can connect our machine learning skills with our real-time data streaming skills. So to do so, let's talk about what ML.NET is. Well, ML.NET is a machine learning library for .NET developers. It was released about 2 years ago, I think, at MS Build 2018 in like preview, and then in general availability about a year ago at MS Build 2019. It's completely open source, cross-platform. You can go into the GitHub page and submit issues and pull requests, and they really love feedback. It's an awesome team that work with this. There's also a GitHub channel. If you just kind of want to connect with the community here, just do so, please. I think the team that works with this really loves feedback and encourages you to submit yours if you have any suggestions or if you want the library to go in a certain direction. What I really like about this library is that it is suited for C#, F#, .NET developers. We can deploy the model in whatever way we want it to be deployed that fits our needs. So we can deploy it as an Azure function in C# or F#. We can deploy it inside our .NET Core application. So it could be just a function called predict or whatever you want to, and you pass in your input arguments and you get back a prediction. It's seamless. It's really simple. Or you can deploy it offline, which is really cool. That's a desktop app. It's a library. It's not a cloud service. So there's no connectivity whatsoever that you need. I don't think there's ARM support yet, but I think they're working on ARM support. So hopefully in the near future as well, we can also deploy it in a Xamarin application offline or on a Raspberry Pi or something like that, which would be really cool because then we have so many of those offline scenarios where we can really do that kind of edge computing scenarios instead. Instead of having the cloud as a central point, we can make our predictions on the edge, right? And get some insight from those things. So it's just one of the strengths here is that the way we can deploy this model. It has some really cool features like AutoML, we'll see that today, where we can do automatic machine learning on datasets. So we can just take a dataset of our choosing, we can kind of pump it into an ML task and say, I really want to predict this column here. So for example, if it's spam or not spam, or I want to predict these classes in these images, we can just push that data into the tool and it will figure out your model for you. It also supports transfer learning for deep learning scenarios, super useful. So if you want to train your own image classificators using Inception v3 or ResNet, you can do so, and it's super easy. This functionality also fans out to Azure Machine Learning now as of a couple of months ago, which is very useful. For example, I got a computer that is pretty strong, but it doesn't have a good GPU. So if I run into these image classification scenarios, I will quickly have a very hot computer that will die. So being able to fan out from Visual Studio to an Azure Machine Learning cluster is just very useful to get accurate models. Something else that we'll see today is that we have Jupyter support, so we can do data exploration and summation in a Jupyter notebook, which makes this tool very useful. In general, when we train a model, what we do is we load our data into a data view. We create a pipeline transformation, or estimators, it is called, I think. I like to call them transformations instead, because it's easy for me at least to get my head around. But what that means is really that you want to add transformation for removing nulls in your data, cleaning up any bad data, creating new features, if you will, those kind of things. And then what you want to do is you want to choose an algorithm to train your model on. It could be a regression, could be a binary classification, something else. And once you're happy with that, you will call a fit method that will get you a model, and the model you can then evaluate with your own different methods to understand if it's really good, if it's really bad, and then this circle starts over again. And eventually you will end up with a model that you're happy with, and you can then save the disk, and that model is going to be a zip file. The zip file you can then load into whatever application you want to, with about 3 to 4 lines of code. And you can create a prediction engine, which you can use to make your real-time predictions, either in the pipeline or in just an ASP.NET Core application. So I know I simplify this a lot, but it's very repetitive. So once you figure out these steps, you will be able to tackle a lot of the same common scenarios and kind of gear it a little bit to your own business scenario. Great. All right. I am done with the slides. And it's only been 20 minutes. Perfect. Awesome. I'll close that. Cool. All right. Again, if you have any questions during this talk, feel free to kind of put them in the chat, and I will try to monitor the chat and ask them as I go. So what we're going to do today? What we're going to do today is actually on my GitHub repo. So if you want to try it out yourself later, go into my GitHub. It's A-Slotte, and you'll find this fraudulent stream here. I put this up so you'll be able to see it and kind of dig into the code a bit more if you want to later. But what we're going to do today is work with a fraudulent data set. So what is the first thing we want to do when we want to create this data pipeline with a fraudulent model? Well, first of all, we want to understand the data that we are going to use to create our model. And there are many ways to do so. You can open up the Excel file if you want to with a CSV file and explore it. But most times this model is just, or this data set is just too large, and Excel is going to crash or something else is going to happen. So what I like to do is look at it in a Jupyter notebook. And we can do that real quick here. Let's see. I'm going to get this over by opening up a Jupyter notebook locally. And I'm using a tool called Interact, which is a desktop application which you can run Jupyter notebooks in. And it has the support of a C# kernel. So you can see here that we can do C#, F#, or PowerShell. And I have a notebook already, I think, for this specific data set. And we won't dig into the details here, we'll just run it and we will kind of see the exploration part here. So if we do run cells, run all, let's see if that works. Actually, I think I already ran it this morning, so we can just look at that. We can't because I took it away. So what it's doing here is it's installing ml.net here as a NuGet package, and again, these details are not so important right now. If you're interested, I have other talks on Jupyter Notebooks, and a lot of my community peers also have great talks on this. But we're loading ml.net. We are fetching the data from Azure in this sense. I have a blob storage where I have this small file on. We are defining the schema for the data, and we are loading that into memory and fetching the first 5 rows and just dumping that to the console here, so we can be able to get a good view of the data. So we need to understand the data before we can build a model, even though it's an AutoML model. So we'll see here we have types of transactions, and each of these rows is a transaction, right? The type is payment. We have amounts. We have the name of the original account, so where it came from. We have the balance of that account and the name of the account it's going to, and so forth. So we have a lot of data here about each transaction, and we'll see that we have transfer and cash out and some other stuff. And one thing that we'll know directly here is what we want to do here is we want to predict if something is fraudulent or not. So we're using supervised learning to do so. And in supervised learning, we already know the answer on the data we're training. So you can see here that we have a column called is fraud, because we have historical data. So we have false or true, depending if something is fraudulent or not. And we'll use this knowledge to fit this column here to the data it has. So when we get unseen data, it will understand the patterns in the data and may be able to output a false or true statement here, right? So there's only 2 choices, false or true, which means it's binary. And which also means what we're going to do today is binary classification. If it's more than 2 choices, we're talking about multi-class classification. If we're talking about a continuous sequence of numbers, we're talking about regression or forecasting. So just keep those things in mind when you try to pick an ML task. They're not so many, so you won't get lost too quickly, and they're pretty simple to distinguish between. One thing that's important though, when we're talking about binary classification, is that our data should be very even. And if you look at the distribution of the data here, we can see that our data is not very even. We have 99.9% of all our cases are non-fraudulent, and a very small sliver here which are fraudulent. Which, to be honest, it's a very real scenario, right? Most transactions in the world is not fraudulent. We are good people. Most people just do their business as usual. So getting fraudulent transaction is tricky. So for our scenario right here, we don't really care too much. We just want to create a model and put it in a pipeline. It's mostly for demonstration. But in a real scenario, we have to do something about this. This is not a good way to get a good, accurate model, because the model can only, the model in essence can guess all the time that it's going to be a non-fraudulent transaction, and it's going to achieve a 99.9% accuracy on that claim, because the training data and the test data is going to have that distribution. So we would need to do something about the distribution here to make it better. All right, so now we know the data. So the first thing we want to do, or I want to do right now, is to train a model. And to do so, what we're going to do is we're going to open up Visual Studio and make sure it opens in the right window so you can see. And we're going to create a new project. And we're going to create a console application for that core. So what we're going to do here, we're going to use Model Builder or AutoML to create our first machine learning model from scratch using the data set you just saw. And to do so, we have to use a console application with .NET Core. And we'll call this fraud. Let's call it global Azure fraud stream. Create that one here. Perfect. See if this loads. Yeah, I'm not sure if you can hear, but my computer is dying of streaming on using OBS as well as doing other stuff, which is I guess a fun thing here of not having a good GPU. All right, so we have a Hello World app. Perfect, we're done. You can sign off now. Machine learning model. Nope. All right, so to train a machine learning model using .NET Core, .NET Standard, and Visual Studio, what you can do is right-click on your project, press Add, and you have a machine learning option here. So as of I think the latest Visual Studio distribution, you may have to go in and enable this setting from the options folder. So what I have right now, I think it's an older version, and this is an extension I'm using called the Model Builder extension. But if you want to use it, I think moving forward, I do think it's built into Visual Studio, and it's like an option in the option setting to just enable it. But you'll get the same kind of entry point, I think. But if you click on that, we will be presented with a scenario picker, which will try to help us and guide us through these ways. So we can do things like simple sentiment analysis, classification, prediction of prices. Deep learning is here, right? Something I haven't tried yet is recommendation systems. That should be really cool. But for our case, we're just going to do custom scenario because we are simple, and I want to kind of walk you through the whole thing. We can choose to have our data from a SQL server or a file. In our case, it's going to choose file. We're going to go to a folder we have this in, and we'll pick the data. So we have a small data set here, which is the same data set we looked at in our Jupyter notebook. If you click on that, we will have a little preview of our data, and we'll see we have 400,000 rows, 11 columns, and we'll get these columns right here. And you can select the column to predict. So remember, this is your answer or your, label. We want to predict the fraudulent cases here. So it's fraud is what we want to do. And we can choose to either use all 10 columns in our AutoML, or we can just choose some. One that I know we don't want is flagged fraud. It's really pointless. So we're going to skip that. And I think we're also going to skip step. Step is like a time measurement, but we don't really need that. But we'll keep the rest and kind of see what kind of model it creates, right? So once we've done that, we can click train here, and we can decide what kind of machine learning task we're doing. So remember, ML task is what scenario we're trying to do here. And we have 3 kinds. But since we only have 2 options, fraudulent or not, what we're going to choose here is binary classification. We then choose the time we want to allow AutoML to figure out a new model for us. And it will spit out tons of models depending on how long you will give it. And he gives you some recommendations depending on the data set. Since we are live here, I'm going to give it 2 minutes and nothing else, and hopefully it will figure out a model in that time. If not, I'll just use a model I already have. So start training here. Press yes on the warning, because yes, my dataset is larger than the recommendation here. And it's going to start off ticking here. And eventually what it's going to do here, it's going to give me models that has trained here on the bottom here. And we'll see things like the trainer, and the trainer is another name for algorithm. So for example, we already have one model, average perceptron binary, and we see that accuracy is 99.9%. And don't really think about accuracy too much, because remember, this model was the data was very skewed, unbalanced. So the accuracy is always going to be high. I'll be surprised otherwise. But what we want to look at here is the F1 score. The F1 score needs to be closest to 1 as possible. And the closer to 1, the better the model. And it's kind of a harmonic mean between something called recall and precision, which is much better metrics for evaluation for this kind of data set. And I will say 0.08 is not a good model. So you definitely want to go with like 0.6 at least, or something like that. But for our scenarios, it's fine. But you actually see here already that we have a fast-tree binary with 0.45. That's a big jump from these, right? And something that we learn later as well is that decision trees are really good at handling these kind of unbalanced data sets. So I wasn't surprised to see a binary decision tree being one of the contenders here for the best model. All right, let's give it 18 more seconds and we should be good here. I'm pretty sure it's going to select the fast-tree binary because I don't think it'll find a better one in 5 seconds. But who knows? All right, so what it's doing now is finalizing this model, and I'm pretty sure it's going to pick that one. And if we look at this here, we'll see that, yep, the fast-tree binary was the best one, right? And it's top of the list here, and it's going to save that model for us, and it's going to generate the code as well that we can use to both retrain the model as well as consume the model. So if we go to evaluate here, in theory we can go in and actually enter some data here and call predict, and we can kind of see how it's doing in general. There's actually a bug in this. I found. I have not been able to use this. So if anyone from the ML team is watching, this is a bug. But because if I click predict here, it's empty. If I choose something else here, it's empty. But it's a nice feature. I don't really use it too much, but it's definitely nice to be able to get a sanity check of your data. But the cool thing and what we want to achieve here is getting the model and getting the code. So we can click add projects, and you will see to the right here how we are adding these 2 projects here to my solution. One is called the console app, and one is the model. So one of these is used to build the model. So if you want to tweak some of the settings here to make it even more accurate and retrain it, you can do that, and it will give you the code it used to train its model. And if you want to just consume the model, you have this consume model method right here. It's called predict with lots of comments, but you see it's very short. You're passing in a model input, which I think you can do this, which is just the schema of your data. So remember, we have the name of origin and balances and amounts, right? Just a schema, nothing else. And it will load the model, the ML context, and it will create a prediction engine based on your input and output schemas. And then you can call predict on input, and you'll get the output here. And the output is honestly just like a prediction and a score. So this is going to be fraudulent or not fraudulent, and this here is going to be how accurate it is, or like how likely is this a good prediction. So it's always a gray zone in machine learning. It's not like always black and white. So for example, we can say, yeah, it's fraudulent, but I'm 60% sure, or 50% sure. So that's it. All right, and the model is a zip file. This is the model. I'm not going to open it up, but it's a zip file, and you can load it in as a zip file as well later. All right. So we have our model. Let's go to our Azure Stream Analytics job now and try to pipe it into a real-time pipeline. And this is where all the fun starts. Well, this is really fun, but I love seeing how we can use these models in the real world. Like, I love examples. I love the AutoML, how quick that is to get started. I also love just building my own models myself. But I'd like to apply them to real case scenario and kind of figure out how I can use them in my professional career as well. So seeing how I can use them, I think is very inspiring for me. So to create our Azure Stream Analytics job here, we can start a new Visual Studio instance and build that. So let's see if this starts. Move this over. So we'll create a new project. Okay. So remember here, I said that you need to have an extension to Visual Studio to be able to create these kind of projects. And that's true. It's the Data Lake and Azure Stream Analytics extension. Because if you have it installed, what you can do is search for Azure Stream Analytics, and you'll have tons of these templates here for a project with some piping and an empty project, your custom deserialization. So for example, let's say you don't want JSON, you want your own funky format. Maybe you want binary, maybe you want just a general object structure. Then you can create your own deserializers. So that's really cool, honestly. I really like it. I can see that a lot of companies would enjoy that. For our case, we're just going to create a simple template solution here. And we'll call this Global Azure Stream. Let's call it Azure Stream. Well, Global Azure Stream. And create. I hope you're all enjoying it so far. Again, if you have any questions, feel free to ping them in the chat. I'm trying to monitor that as well. But second screen. All right, let's pull this over here. Nice. So what do we have here? Well, right here, I'll zoom a bit, is just a query window. Right? You see things like you used to, and with some nice IntelliSense, right? But it's just a query, and that's what you're seeing right here. And to the right here, we have inputs, we have outputs, and some job configs, some other fun stuff. So inputs, you can have inputs from the cloud directly, of course. I mean, that's the whole idea, right? So you can define, let's say I have an event hub, and this is the event hub I'm listening to, and you can like just do that. So for example, I can go, let's actually do that. Double click on my input JSON here, and I get a little bar up here, and I can define my Azure subscription. I can point to an event hub namespace and pick an event hub, and I can start listening to that one and define which format I want to use, which is great. So you can locally kind of query and debug your jobs. Once you're happy with it, you can submit it to Azure. You can put it into an Azure DevOps cycle if you want to, what have you. For our purposes, we're going to use a local input instead, and we're going to spit it out to a local output as well. And the reason for that is because we just want to kind of demonstrate the purposes. Plus, local input is really useful for having low costs, because of course having an Azure Event Hub up and running is going to incur cost. So having a local input during development, I think, is just very useful. So what we'll do here is we'll add a new item, and we'll say input. Now remember, since we have this extension installed, we have these items we can choose from here. And we're going to touch a lot more on these later. But for now, let's pick input. And let's call it a local input. Local input, what's the difference? Local inputs. All right. If you double click on this, we can select what name it has. So we'll call it input. The source. So again, do we want to do like a real-time data stream here, or reference data? So a blob storage or a SQL job. For our case, we're going to choose the data stream. We're going to say that our stream is going to be on a JSON format, and we're going to pick a file. And this file is going to be in this folder here, and it's just a JSON file, very small JSON file. We're going to say, when we start a job, please read this data file and stream the data to me. That's what we're saying. Okay. So with the fact that we have a local input here, let's look at how the data looks like. So let's write a simple query. Select star, so everything in that file, into output, remember into, from input. And we can say input because we've called this local thing input. And output is by default called output, and it's going to be dumping into the window here. So if we say use local input, we can run it locally. What it's going to do is create this schema of the job, and hopefully somewhere it's going to start up. Let's see, I may have to actually build this first. We'll see if it works. No, I think it may work. We'll see. It's starting up this command prompt here on the side, which is giving you some information on the status here. So we see we have one input, makes sense. It's going to build solution, and it's going to kind of unzip it in a folder and run the job in a folder here shortly. And it's going to start a job for us. And hopefully what we're going to see here is the data here coming into the bottom here. All right, so it's working. So we'll see that the input here is, of course, the same format as we've had before. That's kind of what we've done. And we'll see that we have step, and we have payments, and we have all this nice information here on the data. Plus some information about process times and everything else. Okay, so we have the data. Awesome. And if we want right now, we can submit this to Azure. And what will happen is that this will be a stream-analyst job that listens to an event tab, if we configure it as such, and just outputs everything into sync. So this would be awesome if you want to see it in a Power BI dashboard without any kind of smart intelligence on top of this. But for our case, right, we wanted to pick one of these transactions, and we wanted to make a prediction on each of these rows in the data stream, right? That was the end goal here. So let's look at how we do that. And let's start by stopping this one and closing this one. So there are some ways to do this. So what we want to do here is we want to be able to consume our machine learning model. And as you saw, the AutoML tool created a product for us that we can use to consume. And what you can do actually is just add existing project, and we can navigate to that project. I think it's this one, model, and import it. Let's see if this works. All right, so you see, now we have two of these projects here. And we have this consume model right here. So in some way, if possible, right, what we want to do is call this predict function from MySQL. I mean, that would be cool, right? Wouldn't that be nice? We just kind of input the data, we call it from the SQL, and just use our output into that. And yeah, it's possible in some ways. A little tweaking here. I will show you, there's some caveats here. So it's not as simple, but I will show you kind of some things to watch out for here. But by doing this, you kind of get a good template to start with. So to be able to call another function in another project, what you first need to do is, of course, add a reference to that project. So we're going to add a reference to the model project. So now this project knows about this project. We are going to build the solution to make sure we have all the reference up to date. And then we're going to go into functions. So we have a folder for functions. So we want to add a function that the query can then use to call the predict function. So it's like a bridge in between two worlds, right? So to do so, we have a C# function here. So this C# function is also called a user-defined function, and it's been available on the Edge solution or Edge version of Azure Stream Analytics for a while, but hasn't been available for the cloud version until recently. What has been available has been this JavaScript function, which has been very useful for like date conversions and like, you know, small manipulations of data or aggregations that you don't want to do in SQL, but you can do in JavaScript. But you can't necessarily call a machine learning function or ML.NET from a JavaScript function. So it's been a little bit limiting for that world. But if you pick this C# function, we can call it is fraud. Good name, right? And you see it's going to be a JSON file, because what it is not a function, it's just kind of a definition on how to find this function in the other project. If you double click on this one, we have some options here, right? One way we can do this is using existing library from the cloud. So if you don't have all these things local here, you can actually just reference a DLL that you have in the cloud instead, and kind of find a method on that DLL to use for your functions. In our case, we already know what we want to use here, so we use the load from a product reference, and automatically it will kind of look at what you have, and it will find the consume model class, and it will say, oh, yep, the predict method is most likely the one you want to use. Seems to have all the good stuff. But right now, it only has one input, and that is an issue. And why is that an issue? Well, we can't necessarily project this class here, or these separate inputs into a class. So what we need to do is pass in each of these arguments we're using as an input. So let's go to the consume model here and make those changes real quick here. So first thing we want to do is sneak peek at the input, and then we want to add the things we think we care about. So for example, we probably care about type, right? We probably care about amount, and actually it should be doubles, sorry. Well, actually I'll show you. It should be amount. We have let's see, name origin here, so it'll be string. We will have balance here, so let's float old balance org, float new balance org, string new dest, float old balance dest, right? And do I have anything more? Oh, yes, I do have more. New balance. All right, that should be good, I think. So we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, should be good. So now we changed the schema here. So what we need to do then, of course, is to fix this input. We can do that real quick by just saying input equals new input, model input, like, and we'll say, let's define those things here, right? So we'll say the type is type, the amount is amount, the name origin is name origin, old balance origin is. So it'd be awesome if we could actually project this input to the class. So maybe that's something that can be worked on in the future. But for now, this is the way to do it. New dest, and we're almost there. Old balance dest. New balance dest. Did I already do that one? So, okay. Don't think I did that one. Nice. And this one is here. Come on. All right. Cool. So that's how we get the model input, right? So not bad. So we have that, and we have that, and of course we don't really want the model output neither. We want the Boolean. We want a true or false if we are having something good here. So let's check that. That means that we need to look at the predict here, because predict is going to have two properties on it. So what we want to do is the prediction. We're going to pass that back, which is going to be fraudulent or not fraudulent. Nice. All right. So if you build this now, and if we go ahead and add a reference to it, we should have some more properties. Okay, so you see that here. Perfect. So now it looks better. The only thing you have to look at here is that you can't change these, and the end of our char is fine, but the N's here are a bit deceiving. You may have seen, so let's say this first of all. you may have seen that I use floats here, right? Float for amount, and that's because we use floats in machine learning, and we need that for our MLN model. But Azure Stream Analytics doesn't use floats. If I pass in a float here, it's going to say that I can't cast it to a float, and it's going to be angry and it's going to break. And I learned this hard way, and I'm hoping they will adjust this so you can actually change the input value. But what we need here is doubles. So we need to go ahead and change all these to doubles. This is a little got you if you're doing this. And then we need to go and change all these to floats. Very ugly, but I'm showing this to you because I don't like it. But it's the way to do it. Alright. So given that we have that, what we can do now is go to the script, and we can see that, okay, now we have all this good stuff. So if we look at the consume model here, put it on the side so we can see it. Let's put that anchored, maybe. Come on. Anchor it to the side here. We can start projecting these things here. So we'll say, okay, we need type. And nice enough, we have IntelliSense here because we know the data we are using. So amount. Actually, so what we do first is call the UDF function. And you do that by saying UDF. And it will kind of say, okay, it's raw. It's the only one you have, right? So use a defined function. And by doing that, we can actually call this function straight from the query. So we pass in type. We pass in amount. We pass in name origin. We pass in old balance, new balance, new dest, maybe. New dest. Let's see, new dest, name dest, I guess. See. Old balance test, new balance test. Cool. So that is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. I think that's 8. That should work, right? It's pretty good. So let's try that. Let's see if that works. In theory, that should work because what we're doing here is we have defined a function, we have defined the arguments, we're passing it into it, and we are looking if it works. And it's trying to start the job. So let's see if it starts the job. Job starts successfully. So it's passing in these things now. Is it going to work? Dun, dun, dun. So excited. Hope you are too. No, it doesn't work. And actually it doesn't work for a reason that I didn't expect, to be honest. Let's see. So I think it means we have a float left here somewhere. Did we miss a float somewhere? Let's see. Double, double, double. Okay, let's make sure we have the things right here. It's the best part of live coding, right? You have to solve things as they come along. I prefer like docking this one so I can actually see what we have here. Closing this one. So first one, string, amount, name origin, old balance origin, double, new balance origin, new destination, that should be string, name destination should be string, old balance destination, new balance destination. Okay, I think all you need to do here is probably build this and recreate a function. I've seen some issues sometimes where it just doesn't want to re-understand things. So if we look at this one, yeah, so now it's looking better here. So let's try this. Save that, build that. And you saw that it was saying float, right? But it actually is deceiving because it doesn't want floats. It wants it once doubles. But let's see. I'm hoping to get an other error here actually, but not the error I'm getting. So let's see if we get the other error instead. Started, perfect. All right, perfect. I think good. All right, so we are past the casting issues, right? But we're still getting an error. And why are we getting an error? Well, let's debug that. We can actually debug things here and understand what error is. So we can put a breakpoint in our code there, which I think it's really cool. It's really helpful. And we can put a breakpoint from SQL to C# code. Think of that a bit. SQL to C# code. And if we don't press run locally, if we press debug instead, let's close that, close this. We press start here. Just debug it as a normal application. We should be able to get some interesting information here. It's running, starting up. Are we hitting this breakpoint or not? Let's wait for it to start. I think it's really cool. SQL to C#, who would have thought? Let's see. All right, it started. Breakpoint, bam. All right, so it's breaking, but where's it breaking? It is obviously getting all the information here. We can see that we have our inputs and they are correctly transferred. And we're creating an ML context and we have our model path, and this is the path to where we have our model, right? And sorry, excuse me. Now we're going to load our model into memory, right? So we're taking a model, we're giving it a path. Here's my model. Please load it to memory. What is happening here? It's throwing a target indication exception. And what is it saying? It can't find fast-tree's DLL. So fast-tree, that is the algorithm we decided to choose here for our model. And we have that dependency as a package here. And we have ml.net here as well as a package. But it's saying it can't find it. Strange, right? Well, it's actually a little caveat here. You can, if you want to do what I just did, to just kind of import an existing project from AutoML, what you need to do to make this work is actually have these packages as assembly references instead and copy them always out to the output directory to make this work. Otherwise, Azure Stream Analytics is not going to load them correctly and it's going to kind of just mess up. But there's a way around this, and I'm going to hack this a little bit. And the way to do this is add an existing project to get some more information. Oh, new project, sorry, new project. And we can create a project. It's called a C# UDF. So this is a user-defined project. So this is a project specifically designed to be used when creating C# UDF functions for Azure Stream Analytics. So let's call it predict UDF. It doesn't matter. We're not going to use it. We're just going to steal stuff from it. If you create that, we see there's two things that come with this that didn't come with a standard project. The first one is a target here. So we have targets for how we build. And some of these targets is going to kind of, from my understanding at least, take some of that packages and take those DLLs and copy them to the right folders that is used when we start a job. So we need to have this target in our project. So we just copy it in there. And we also need to have the instructions in our project file to make sure that these things can be copied correctly. So we're just going to steal this. This is we actually only really need these, I think, here. But let's steal everything here. Property group. Yeah, I think we'll steal all of it. And we'll put it in my other folder. Let's not steal all of it. Let's steal this. And we'll put it here. No. We'll put it here. So you don't necessarily need to do all this stuff, honestly. Like this is definitely overcourse. What am I missing here? Property group. Okay. You don't need to do all the things. In general, what I would suggest is just create a UDF project from scratch. You start that instead, and then you create your code in that one instead. And you can just import your model, and you can do your own code. It's really simple. But I'm just showing you this to kind of make sure you see this because it's different, and I've run into so many bumps in the road along the way with this kind of difference here and this nuance here. So I'm hoping that by showing this, I'm going to help someone out when they're doing a similar issue. All right, so we've done that. If we now build our product again, what we have done now is we kind of told this project on how to copy the references out in such a way that it'll be useful for the project. So if we run this now, we have our solution starting up here. What I'm hoping here is I'm hoping that we will get something out. But we will see. It's not certain. So waiting for that to start. Started. Let's see, do we get any issues? Ta-da! It is working. So we are now getting projections on each of these transactions that we get in our stream. We're getting a projection. And of course you can say, you can call this as something, right? As the same way as you do in SQL, you can say is fraud 1 or 2, whatever. And you can also pass in other things here as well to this projection. And if you submit this to Azure and kind of hook it up to an event tab, there you go. You're going to have a real-time data pipeline using a C# UDF function that is not using an Azure machine learning service or anything else in the cloud, but you're actually using your own local machine learning model piped into a real-time inference pipeline, doing some real cool stuff. So I think it's perfect. I think it's really nice. This is something that I'm super happy that that team have worked with and figured out. And I think this is so many cool use cases for this scenario. One thing I really want the Azure team to fix, and I'm really hoping and pushing for this, is adding support in Azure Machine Learning for ML.NET. Right now you can only do Python and R, but you have all of that flora of models, right? So you can do H2O models, scikit-learn, those kind of things, but you can't do ML.NET and C#. And I would really like them to kind of add support for that, so you can expose an ML.NET model in a cluster or something else, which would be nice. In that sense, you will actually be able to use Azure Machine Learning for these kind of scenarios too. So, well, with that, I passed the hour I wanted to allocate for this, and I've kind of dug into both ML.NET and showed you how you can create and train your model from scratch. I have showed you how you can set up your own stream analytics job to just stream data in general. And I also showed you how you can connect those two worlds together into a real-time streaming pipeline in not too much time. Less than an hour, right? So I'm hoping you have really enjoyed this talk today. And if you have any questions again, just feel free to reach out to me on Twitter or LinkedIn or somewhere else. Again, I want to mention again that at the end of May, John Wood and I are organizing a conference called the Virtual ML.NET Community Conference. If you have something you want to share, your journey with ML.NET, something similar, please submit a talk. If you just want to attend and learn new things, register to make sure we are, then you know you will be there. And I hope to see you there. It should be a really fun event. Let's build a community together. All right. Thank you very much. Have a good day, guys.